Good afternoon and welcome to, oops, that's not right. Yes, welcome to Comp 422 and Comp 620 Information Privacy and Security. Today we're talking about cloud security. Not going to talk about data harvesting like the schedule originally said. I made that up way back in August and I don't know what I was thinking. Seemed like a good idea at the time, but I thought we haven't talked about cloud security, so we're going to do that. I have a couple. We'll talk about cloud security. We'll talk about the exam. I'll talk about backups today. Okay. All right. Cloud. What is this cloud thing? You hear about it all the time. Basically, instead of the old model where a company would own their own computing equipment, they lease computing resources from a company, a cloud service provider or CSP. That way, the company doesn't have to put out money. And a lot of these computers cost a lot of money. If you have a bunch of servers, a lot of networking equipment, also the people to maintain it, the air conditioning, the power, it all adds up to a bunch of money. Now, of course, when you have somebody else do it, it's going to cost no less, but at least they get to do it. Also, you may not need your computing power all the time, and you can buy it from the CSP to use it as you need. Also, the CSP will have experts. They can keep the system running smoothly and securely. Security is what we're going to talk about today. So basically, it moves all your computing resources to the cloud. Instead of having your own computer down in the basement, the computers are someplace in the world, don't even know what country they're in, and you're accessing them through the network. This is quite a shift. Companies which used to have their own in-house experts to run their machines and manage them no longer need that. Well, of course, doesn't mean that computer scientists are all going to go out of business, because the cloud needs cloud infrastructure. The cloud service providers need those people. There are multiple models, and we'll talk about those in just a minute. And they provide all sorts of resources: storage, computation, networking, and you can purchase all these. There are a lot of examples out there that regular people use cloud service. Google Mail, Gmail. Gmail, you access it usually on a web server or maybe an app on your phone, and it's really all happening in a server somewhere, someplace in the cloud. So you're, but it looks like you're using it right there on your desktop, but it's actually happening someplace else. Your A&T student email, anything with an aggies.ncat.edu, is actually managed by Google, and that's happening someplace in the cloud. Also, web servers are frequently managed in the cloud. Not too many people have their own web server machine anymore. They hire the service from somebody. We talked a little bit about the HTML, the get command, which is the most basic of all the commands. Starts with a get, and the page you want, stuff. And then what used to be an option is now required. It's a required option, if that makes sense. You have to say what the host is. Well, the reason for that is because many of these websites are hosted on one machine, one large, powerful machine that handles all sorts of different companies' websites. So maybe it's www.acme.com and www.widget.com and whatever. And by putting the name of the company here, they know what website you are going to. So the web server looks at this as, where did you want to go? What website do you think I am? Oh, I'm acme.com. And it then gets the page from acme.com. If you put widget.com, it'll get the page from widget.com. And it puts them all in the same machine. Makes it a lot easier. Particularly, you're going to have a machine that's powerful enough to handle all the web activity that you need. And if you have your own server, in order to be powerful enough to handle the occasional frequent burst of activity, it has to be idle for much of the time. You don't have to worry about that when it's not your machine. There are all sorts of cloud service providers out there. The major companies in the world are all providing web services. Amazon, Of course, Amazon is doing. Amazon has a huge server farms, plural, all over the country. A couple here in North Carolina, and they have an online business, so they have to have lots of servers. And around Thanksgiving, Cyber Monday, they're using a lot of those. But the rest of the time, they may not need all that computing power, and they sell it to other companies. Same thing with Microsoft, Google, of course, lots of computing resources. Alibaba, that's the big company in China. IBM's got one, Oracle, all the big computer manufacturers usually have their cloud service that they sell to anybody who wants to buy cloud services. Now, the cloud works, but it has some issues. The network, everything goes across the network for cloud activity. You're not just talking to your local computer. It's not like you're talking to your desktop. Everything goes over the internet, and all the internet dangers that we talked about appear in the cloud and more. So you have to watch out. Basically, you want to make sure everything's encrypted as it goes over. There are several important features of clouds that people want to use. This is not a security issue. Why do people have that? Elasticity. That means you don't have to buy all the resources you might maximally need. You can purchase them, and if you grow, your system grows, you need more and more resources, the cloud service provider is more than willing to sell you more resources. Some of them will allow you to vary the amount of resources you're using almost instantaneously. They can easily scale up or scale back so you can get more resources when you need them, and then when that peak rush goes away, everything goes back to using fewer resources. And they charge you that way. You pay for what you use. When you are using lots of resources, the bill will be bigger. Although when you're not using a lot of resources, the bill will be much smaller. If you bought your own computer, you basically have to buy enough computing resource to handle the rush, to handle the maximum amount of usage. You don't have to when you do the cloud. You can expand as you need to. So you can provide a company with lots of computing resources that they need when they need it, and don't have to pay for it when they don't need it. Also, they have the expertise out there to make these changes. There are several cloud service models that I'm sure many of you know much better than I, but I'll go over these service models briefly. We'll talk about how that impacts security. All right, there are three major models that you might see. There's infrastructure as a service, platform as a service, and software as a service. They each add on top of each other. Let's go over each one of these individually. Okay, infrastructure as a service basically provides you what looks like your own computer, and you can do whatever you want to with your own computer. You can put your own operating system on it. You can run your own software. They just provide computer. It's a virtual machine. But yes, it looks like you have access to this machine, and you can boot up your own operating system where you want. Do you have a question?
I was not sure. So I just was the most capabilities.
Well, it depends on how you define capability. Basically, infrastructure as a service provides the least amount of the cloud service provider provides the least amount of service for that, but you can do whatever you want to. In particular, the big thing here is if you want to run your own operating system, you can do that. That's useful if you're running something that's different. If you think you need to run a Linux operating system, you can boot it up on your cloud machine and run your Linux apps on that. Use the most flexibility, I'd say. Let me go for a few more slides, and I think I'll answer that question. Yes, and again, the user, that is the customer, the person who wants this IaaS service, uses the machine. They don't have to worry about hardware. It's out there, it runs. They put the boot image out there and boot it up, and it boots. Good, runs. and it has storage, and it has network connections, all of which is maintained by the cloud service provider. Then there's platform as a service. This is the next step up where they provide the operating system and some basic utilities or infrastructure software, such as virtual machines, networking activities, the usual stuff that you find. In other words, you can run whatever applications you might have, but you don't have to maintain the operating system. They give you the ability to load your apps there, and you can run them up there. And then there's software as a service, where they provide the applications. Particularly, this is where you have web servers. In software as a service, the cloud service provider will have a web server out there, web server software, something maybe Apache or Microsoft's information server, and you can just, all you have to do is put your pages on a directory, and then you can get them. They take care of the operating system, they take care of making sure the software, all the infrastructure is running, particularly web servers. You don't have to manage the web server itself. You just put the data out there, and then make sure it appears on the websites whenever people want to go and see your information. Then the next one, which is not always included, but storage as a service. That's where you provide just mass storage space. You want to keep your information someplace, you can put it out there. This is be very useful because it's also off-site. It's someplace else. You can store things out there and manage it. So I like this slide. This slide shows you we have the left is on-premise. That is the traditional model where you buy your computer and you manage everything. You have to worry about the networking, the storage, the servers, all the equipment, the hardware, the operating system, all the middleware. That's all something that you manage, that you buy, and you manage it yourself. You have to have an in-house staff to take care of that. The infrastructure as a service is where they provide the hardware, the networks, and then you can boot whatever operating system you want on that and run your applications and data on that. And then platform as a service is where they provide all the middleware, the operating system, all that sort of stuff. And so then you just have to provide the data, maybe some applications. For instance, if you have, web-based applications, I'm thinking PHP or something, a database, you don't have to worry about maintaining the storage, but you're allowed to have a database. Like the database software is probably there. You can get access to the database. You can put your data out there, your tables out in the database, and access it from your web applications. All that's there, but you don't have to set that up. Yes.
Yes, what, these are called privileges, right? What privileges?
Well, yeah, I see. More is provided for you as you go on. Again, software as a service, they run. All you have to do is put your data out there, and it goes.
Which one will cost the most? The software service cost?
Oh, pay for it. You have to pay probably more for software as a service than infrastructure as a service, because if you look, the orange here is what the cloud service provider provides, and over here on infrastructure, they don't have to worry about maintaining the operating system or anything else. That's all your responsibility. Whereas on the far right, software as a service, they maintain everything, and of course, they probably charge you for that. I like this picture I got from this website down here. It represents pizza as a service. It's a good analogy for the software as a service. Okay, if you're going to make your own pizza, then you got to worry about the cheese, the toppings, the dough, all the stuff on top. You have to have the stove, the tables, all the things you need to do the pizza. Now, you could go to the grocery store and buy a frozen pizza, in which case you don't have to worry about the dough, the toppings, and all that. You just buy the frozen pizza. You have to have an oven to cook it in, all the utilities, something to drink, on the dining table, but you don't have to worry about the basic. Over here with platform as a service for pizza, they cook it for you. You just have to, that's like pizza delivery. comes, it's cooked, it's made, you just have it. And then dining out. Dining out is the equivalent to infrastructure, excuse me, software as a service where they do everything. You go in there, you sit down, they bring it to you. They provide the utensils, they provide the table, the drinks, it's all there.
And that ties in that personal mistake. It's as a service, it makes sense that, like, take the big cost less than dining out.
Yes.
So it's,
Right,
costs more.
yes, so yes, which is what costs more, of course, dining out costs more, as does software as a service, because they provide more. All right, I got a question here. See what people need. Your card?
Do we have last Wednesday? Because I got my computer.
Yes, we do have class on Wednesday. We're doing a review. I'll talk about that shortly. And I have these clicker cards. If anybody has a clicker card, one back, one. Yes, good. Have one of the clicker cards. Please return it sometime. Or if you can't find me, just put it in my mailbox in the computer science department. I kind of like them back, paid for them. And there. Oh, I'm sorry. I didn't start the, nobody said anything. I know you don't want me to run these polls. This one's, okay. We're on. Oh, sorry, that was. Oh. All right. Let's see this coming. All right. Well, we certainly have a difference of opinion. Let's see, we've got 69% of the people participating, 100% of the people in class participated. Okay, let's. All right, the results are mixed, but okay, we want to run a different operating system. So it's unlikely that the cloud service provider provides this as an option when you want to run it. So you're going to have to boot the own operating system yourself. You're going to have to provide the operating system. Nobody runs IBM MVS. Well, actually, take that back. There are companies that run IBM MVS still. It's an ancient operating system, but it runs on some IBM servers. And IBM tells me if you can get students who know MVS and COBOL, an ancient programming language, they will find a job for you. There's still companies out there running that stuff. Okay. This is where you'd want to have infrastructure as a service, because all you need is something that's virtual hardware and you're going to boot your own operating system on top of it. Okay, let's move on then. All right. If you will. Okay. Traditionally.
Professor, what will be the answer of that question?
Oh, infrastructure as a service, that would be, you'd want infrastructure because you want to put your own operating system on it. The operating systems that the cloud service provider are probably much more modern operating systems like Windows, Linux, something else like that. You don't want to run MVS. Well, you probably don't want to run a new system with MVS.
Thank you.
Okay. Okay, well, once upon a time, not very long ago, you had your machine, you booted up your operating system on it, and you ran your applications on top of that. Each application got its own resources and it ran, and you could run multiple applications on the machine. And sometimes they interacted and sometimes they didn't. Sometimes they were supposed to interact, sometimes they were not supposed to interact, but they did. Or you can have one machine, have it be a web server, have it be a DNS server, have it be an HTTP server, all these things at the same time. Virtual machines have been around for a while, helping to help users multiple applications, multiple things running on the same machine. Long ago, that would be early 80s, I think, 1980s. I worked on a system, IBM VM370. It was a very good virtual machine system. When you logged in, it booted up a simple little operating system called CMS, and that's what you ran, which ran on top of the IBM virtual machine. And you could issue commands to the virtual machine if you needed to do something, but it was pretty. There are many virtual machines now, all sorts of software that you can buy. You probably know VMware, VirtualBox, several others that you can get. Some of them are purchased products. Some of them you can get for free. Most of the times you can get a free version or pay if you want more. And then in this virtual machine, you can run different operating systems. So in this case, you could have a virtual machine running on your desktop, and inside that virtual machine, you could run, say, very common, if you have a Windows system, you might have a virtual machine and run an Apple application inside the virtual machine, other way around, or run Linux or something. Of course, Java, when you run Java programs, it runs in the Java virtual machine. When you compile your Java programs, it takes the source code, compiles it into bytecodes, into class files, and the class files are executed by the Java virtual machine, which runs on everybody's machine. Lots of virtual machines out there. One of the big advantages is they can provide hardware independence. Again, you can run your Apple stuff on your Windows system or the other way around. Yes, question.
I use like a virtual machine. I went into a
Oh, yes, somebody mentioned that performance on a virtual machine may not be real good. That is true, particularly if the virtual machine is running a different type, is trying to support a different type of hardware. If you have a Windows system running on an Intel chip, you can run a virtual machine that supports Android development, which if you want to create an Android app, do it on your laptop, and then you can run it on your real phone, or you can run it on a simulated phone. I think the Google Android simulated phone is one of the slowest applications ever found. And everybody will tell you that it runs very slowly because the telephones run usually an ARM processor and your desktop runs an Intel processor. They're not the same. And so for each instruction, it has to figure out what does that do and execute the Intel instructions to do the same thing. And then there's all sorts of other issues about virtual memory, page faults, interaction between applications that have to be maintained, but are not maintained naturally on the virtual machine. So yes, sometimes. Now, if you're just running a virtual machine on your computer, that's all you're doing, you can get virtual machines that are very efficient, but you're probably running a virtual machine on top of your desk, your desktop with everything else. Yes. There are virtual machines you can boot up on your system instead of booting up Windows, then boot Windows inside the virtual machine along with other things.
Well, there's more RAM, there's more RAM you have.
Yes, if you have multiple virtual machines or virtual machines, and they all think they've got 16 gigabytes of RAM, and your real hardware has only 8 gigabytes of RAM, well, it's going to make it work, but it may be slow. If you have lots of memory, then it won't have to do all the paging. It's not a requirement. People keep thinking, oh, you have to have lots of memory. Well, no, it will run. In the operating systems class, they should have taught you about virtual memory. Virtual memory works, but it's slower than real memory. On the other hand, we have really fast solid state disks these days, and paging is pretty quick. Okay, moving on. So virtualization, again, the virtual machines make it look like you're running on a real machine. You can put your own operating system out there, boot it up, run your databases, your middleware, your compilers, all your applications inside the virtual machine, and all the applications in the operating system think they're running on real live hardware, but they're not. There are a few occasional things that are different. Again, I think I mentioned paging. Paging's a challenge for a virtual machine, but we're not going to talk about that in this class. One of the nice things about virtual machines is they provide independence. If something fails in a virtual machine, the whole system does not go down. If you have multiple applications running on one piece of hardware and one of the applications fails, it may have impacts on the other machines running, other applications running on that machine. If you have multiple virtual machines and some application inside a virtual machine fails, well, you can just restart that virtual machine and the other applications and the other virtual machines totally unfazed. The only impact, though, that if one application in one virtual machine is consuming a lot of resources, consuming a lot of the CPU time, well, that's CPU time that the other virtual machines will not have. So there is some sharing of resources. Now, this is a security class, so we're going to talk about the usual confidentiality, the CIA, confidentiality, integrity, and availability, and how that impacts clouds. Cloud service providers frequently will tout their security. And one of their advantages is that they have people on site who they can afford to hire experts because they can have an expert to support many customers, as opposed to each customer having to hire their own. And of course, they want to make sure that the data is not released, the data isn't changed, and that machines keep running. Here's another question for everybody. So let's see if I can get the polls. Server. Oh, wrong. Sorry. Zoom was not behaving. There it is. Okay. All right, let's end the poll. There's your results. Yes, a lot of people picked D, which is good because D is the correct answer. Yes. Oh, well. Cloud servers are used by a lot of people. Again, you can use with Gmail. They often use it. Oh, always use virtual machines. That's not quite correct. I guess B was the answer. Oh, well, okay. Silly question. Never mind. Yeah, I think they don't always use, they frequently use virtual machines. They're used by everybody and generally support multiple users. I shouldn't have said always. I should have said frequently. Oh, okay. Big question is what's different about cloud security than non-cloud security? The answer to that is not much. One of the big things is you're having your system managed, including the security of their system, managed by people who are not your employees. You're hiring a system, and they may or may not be as trustworthy as you wish. That's, of course, generally you can assume that they have a certain level of trust. But if you have highly sensitive data that's worth a lot of money, or has other sensitivities, say security issues, you have to watch out who's who has access to that data. Encryption will help you a lot with that. Okay, what are the issues with cloud security? Account hijacking, that is somebody getting access to your cloud. Visibility control, you have to see what's happening. Again, you are using the tools that they provide, and it's being managed by people who you don't know. You have the data going back and forth across the network. And there are maybe multiple users, other customers who are using the same machines you have. Here's a diagram that kind of shows a little bit. We have customers here in these boxes along here. Some of the threats, there's multiple threats going in many directions. There's one threat between the customers interacting with each other. There's a threat between what threat does the cloud management have to the customer, and what threat does the customer have to the cloud management? And then there's external threats, threats from outside. External threats are same sort of things that you see in non-cloud systems. All the threats that we've talked about this semester that happen on regular computers or non-cloud computers are there on cloud computers. They don't go away. So all of these issues, all the others outside can attack customers in the cloud. Guest to cloud, these are where the guest can threaten the cloud service provider. Yes, so the guests can do something to attack the infrastructure, and if they do that, it will impact the other users. There's the other way around. There's the, so this still get, more on guest to cloud, particularly if they attack the virtual. Remember, this thing boots up or has a virtual machine image, which doesn't always have to be booted. You can often stop your virtual machines. It just stops it, saves everything to a disk, and you come back and start it, and it starts back right where it was. But if somebody changes that image, somebody changes what's in memory, what's going to be in the virtual, then they can really make a big change in your system without you knowing it. Putting in viruses and other things. And they have the term hyperjacking for that. Then there's the cloud to guest threats. This is where the cloud service provider provides a threat to the customers. Typically, if you have employees that are not trustworthy, that don't always operate. Many of the people managing your security, managing your system are not your employees. And you're not always sure about while you hope that the cloud service provider provides all sorts of physical and system security on it, you're not always sure that they have what you need. There also may be insecure interfaces, APIs, that is access to systems through functions you call through HTTP. A lot of those on the system, and they may be vulnerable. Is there a question?
Also,
The cloud to guest means that's the cloud service provider is doing something inappropriate to the data of the customer. Okay, another quick question. This is true or false. How difficult can it be? Let's try this one. I can find it. There they are. Yeah, try this one. All right, there we go. Two B's and an A. All right. Well, how are you online here? 50%. And there's always the wise guy. Good grief. Okay. The answer is true. Almost all the security things that we talked about during the class that apply to traditional non-cloud systems also apply to cloud systems. All those threats still attack your and there we go. Storage security. You could have storage as a system where you're out there. Again, everything's going over the network. You have to worry about network security issues. And the of course, the advantage there's a cloud service provider has the people to maintain the security of the system, and they are responsible for backups, which are very important. And I'll talk about a little bit more today. There are a lot of cloud service providers. You've probably seen these things: Microsoft OneDrive, Google Drive, Dropbox. Probably use some of those. A lot of people use personal use of cloud. You use it on your laptop. And the advantage of that, big advantage that they pose is you can have your data accessible by all your devices. So you can have data that you're using on your laptop, and you can also access it on your phone or on your desktop or whatever you want. Of course, I point out that the good network connection is required to do all this. Microsoft Windows really thinks their cloud Microsoft OneDrive is the greatest thing in the world, and they now make it the default. Not just a couple of years ago, your My Documents directory or your Documents directory was on your C drive. It no longer is by default. It is now stored in Microsoft OneDrive because they figured, oh, that makes it so much nicer for you to be able to access it elsewhere. Of course, that means you have to have good network connections. You can change that and put your Documents directory on your desktop. And that's it for the cloud. Okay. Okay, let me start up again here, and I think I'll just spend a couple of minutes talking about the exam. Zoom, there we are. Okay, we're back. Hopefully you can, yes, you can see the exam. All right, just a reminder, maybe. There, it's the grading scale. Get back to that. Here's the results from the third exam. Of course, you know how you did individually because I emailed a summary of your grades for all the work this semester. It's got your, all 3 exams, all your homework stuff is all on that page. If you think there's a mistake, and I might point out there's about 80 students in the class, there are multiple assignments, lots of numbers out there. The possibility that at least one of them is wrong is rather high. So if there is a mistake, let me know. The thing you know about the exam here that you'll all be happy about, you know how you did individually, is look at all those A's, more A's than almost everything else. A's, a couple B's out there, some C's, the pluses and minuses tend to be smaller because if you look at the grading scale, you'll see that there's a smaller range for pluses than there are for the whole letter grades. And there it is, lots of A's. There are still a few bad grades out there. Okay, so I took your 3 exams. Each one counts 20% of your semester grade. I took all of your assignments throughout the semester, threw out the worst one, averaged the rest, and that counts for 20% of your grade. And put it all together, and that gives me a score. Here's how those went. Again, lots of A's. There are a couple, again, there's an F or 2. Most of the F's, by the way, are students that gave up. They didn't take the exam, haven't done the last several assignments. I think they just sort of gave up and decided they weren't going to do this. Yes, if you're going to give up, do give up before the last day to drop and drop the class. Now, in the email I sent you, I mentioned that people were or were not exempt from the exam, whether you were required to take the final exam or whether the final exam was optional for you. Only if it says the final exam is optional, do you not have to bother to take it. If I said it was optional for you, then if you do not take the final exam, you will get the grade that I sent to you. So if it says you've got a B plus and you don't take the final exam, you'll get a B plus. You may, if you wish, take the final exam. And if you do well, if you got a B plus, you could do well and get a A minus. On the the email I sent you, it tells you how much better you have to do on that final exam in order to improve your grade. By the way, that is the number to improve it by 1 notch. So if you're going from B plus, it would be B plus to A minus. If you have a C, it would be C to C plus. It's going up one of those little increments. Of course, if you get a really good grade, you can jump to more increments than that. Or if you get a really bad grade. Yes, question everybody asks, if I got a bad grade, will my grade go down? Yes, it will. Now, having said that, say you choose, if it's optional, you go out there, 6 o'clock, Monday morning, 1 week from today, 6 o'clock in the morning, you open up that final exam, you start working on it, and you go, oh, I don't know this stuff. Well, don't submit it. Just press the cancel button at the end, and if you don't turn it in, it won't get graded. So you can decide. So, but once you press that submit button, and you're all done, you've answered all the questions, and you go, yes, I'm done, then you've done it. If you did a really bad job, get a really bad grade, yes, your grade could go down. And it has been my experience that rarely, very rarely, does a student screw up so much that their grade goes down, because they usually don't take the final exam. So, okay. Now, if it's required, it doesn't matter. If you are required to take the final exam, then next week, Monday, take the final exam. Just like any other class, you got to take the final exam. And it will be 20% of your total grade. Are there any questions about this concept of being exempt from the final? Yes, sir.
You have a good grade. Take the final the grade and information which you email us as you have to stay in.
Yes, if you have a good grade and the final exam is optional for you, then if you don't take the final exam, you will get that good grade that was on the email that is sent. So particularly say you got an A. Several of the people who are not taking the final exam have A's, because if you have like a 98 average, well, you're not going to do any better, and you're not likely to do any worse. So why bother take the final? Why should I bother grading it? You can see self-serving here. I don't want to have to grade this thing. So you're exempt. Yeah, so if you like that grade, now, if it's not an A, and you think, yeah, a B plus isn't a bad grade, but I might want to go out there and try to do really well and get an A minus or an A, you can do that. And again, if you think you screwed up somehow, it's just not your day, you can always press the cancel button at the end and not submit it. Or alternately, by the way, if you press the submit button and it's before the end of the test period, it was before midnight on Monday, December, was it 11th? Yes, December 11th, next Monday. Then just email me and say you choose not to take the final, and I'll just discard it.
So you have an option, right? Or open the funding. So you can
Right, yes. If you use the paper analogy, I handed out the exams and it was optional for you. You could look at the exam, answer some questions, decide, oh, I didn't prepare well enough, and then just walk out of class with the exam in your pocket. Oh, well, first of all, if you press the cancel button at the end, after you answer the questions, you have to press submit at the bottom. Don't press submit. And send me an email. Just send me an email saying, I do not wish to take the optional final exam to count, and I will just discard it. Okay, so you can give it a shot. Yes, so there's no real danger in trying, because if you try, you'll probably know whether you got the idea, you know the answer to this or you don't. Hopefully, there's no real gotchas in grading it. Yes.
Can a student now, or this Monday, even say you're getting something, I'm gonna opt out, oh, we are, that's open.
No, if it's optional, if the exam is optional, you're done. You are done for the semester. Don't need to show up on Wednesday, or don't need to get out of there on Zoom. Ms. Artis, do you have a question?
Yes, sir. What is the cutoff in regards to the numerical value for not being able to take, well, not being optional for the exam?
It's not a number for everybody. Here, okay. I have a algorithm on my spreadsheet. It's all numerically determined. And sometimes my algorithm doesn't have much of a soul. So if you think it was picking on you, let me know. But basically, if you have to go, if the grade you have to get to go up is more than 5 points better than the best test grade you've ever had, then I don't think you're going to do it. And so I say, well, it's optional for go. I make up an exempt going up, an exempt going down, and then I merge them in and figure out whether you are totally exempt or not. It's yes, but it's based on how you've done in previous exams. Basically, is the grade you have to get to go up outside the range of grades you received previously? Does that answer the question? I know it's not as clear as saying, oh, you have to get this number and you're done. It depends on yours. So two students might have the same overall semester average. One may be exempt and one may not be exempt, because the say you have an average of 75 and you got a 74, a 75, and a 76 in the 3 exams, and you have to get an 85 to get it. Well, you've never gotten anywhere close to it if you're 10 points off. Whereas another student who might have a 50, a 75, and 100 on their exams, well, then if they have to get an 80, that's within the range. They've done that before. So they will not be exempt. I know students hate this because it's not real clear, but it's based individually on your previous grades. If you don't like my decision, please send me an email and I will review it.
Thank you.
Do that before next Monday. Okay. All right, the final exam. Yes, what about this final exam? I think I mentioned this before. It is 6 a.m. in the morning till midnight on Monday, December 11th, 1 week from today. It will cover material from the entire semester. I will talk about that on Wednesday, what we are covering. And so here you are. We just talked about cloud security, final review, review for the final, yes. And then, okay. Any questions about the exam? Before you all disappear, I have one more set of slides. Yes, boy, he's been busy. Second.
He's about to go to change. I was like, actually, about.
Yeah. Yeah. We talk about canaries later.
Yeah, Crystal.
Oh, okay, there's a question. We have a question about the canary question. That's question 4. Yes, question 4 on the exam. A couple of things to remember. One is you have to have 8 characters that will go into the name, followed by 4 pound signs that will overwrite the canary value, overwrite them without changing them, and then 1, 2, or 3 characters to go into the employee discount variable. You don't want to use 4 characters because remember in C and C++, it indicates the end of the string with a null character. So if you put 4 characters into the employee discount, They all go into the point of discount, but the null character will go into the canary afterwards, and it'll be detected. Okay. Okay, moving on. Yeah, okay, we're seeing that. I want to talk a little bit about protecting your data, which is important. I'll tell you why. And it's a very important topic for information privacy and security. First of all, the computer is going to break. It will break. It is mortal. It will die sometime, particularly your disks. It seems to be the big point of failure. That's where your data is. If your CPU dies, which rarely does, but if it dies, you can pull your disk out, put it someplace else, and continue without losing your data. But if your disk dies, your data is gone. There are all sorts of ways to lose your data. User errors, that's the factor. You press that button and all of a sudden you realize, oh, I shouldn't have done that. That happens. Disk failure, that's the old hardware, the disk breaks, things go spitting out, it's broke. Data corruption, file system, for some reason, things happen. Suddenly, the operating system doesn't think the file system is correct. There's lots of files. The operating system can break. Power failures. If you lose power, the operating system keeps a lot of your information in RAM because RAM is really fast compared to your disk. Even if you have solid state disk, it's pretty fast. So it saves it there, keeps it from going out to the disk a lot. But if the power goes out before it writes it out, you lose it. That's, by the way, a very good reason why, if you're concerned about this, well, desktops don't have to worry too much because laptops don't have to worry because the laptop has batteries in it. At home, I have a desktop and I have a uninterruptible power supply. It's a battery pack that plugs in the wall. Now my computer equipment plugs into the battery pack and it does surge protection. And if the power goes out, then it provides power to my computer, 110 volts from the battery. And that will run for a few minutes, depending on what it's doing. And it usually gives me enough time to go, oh, lights have gone out. I'm sitting here in the dark. I better do so. You close all your applications, power it down, and you're safe. You didn't lose anything. Of course, malware, we've talked about that. And don't forget theft of the equipment. Somebody just steals the whole box. Here's a chart I got for what causes errors. Hardware failure is the number one item out there. The disk breaks and your data is gone. But notice that human error is a huge chunk of the data. That's where something happened. And then there's some sort of corruption, operating system or the file system. All of a sudden, your disk drive is not in the proper format. There are tools to fix that. Apple and Microsoft all have tools that if something's wrong, you can say, try to recover my disk drive, and it usually can do a pretty good job. Not always. It says computer viruses. That means malware. I think that number has gotten bigger. This is probably an old chart. And then natural disasters are only a small percentage. You will note that it is less probable for somebody else to destroy your data than for you to do it yourself. The human error is larger than, so statistically, you're more likely to destroy your data all by yourself without having somebody else help you. Okay, I have a couple clicker questions here. These are personal questions. There's no right answer. It's just going to ask how you do it. So let's get these polls open. And that's the there we are. Okay. You got it. Just tell me. Don't want to say. Yeah, the hard drive is probably what's the fastest. It's probably the most reliable. All right, let's see what we're doing here. Yes, most people use a hard drive. Oh, hey, we got somebody out there using a thumb drive. I would not recommend doing that. Thumb drives are not as fast and they break and they get lost. As long as you have your laptop, you're not likely to lose the hard drive inside of it. That just doesn't happen very often. A thumb drive, on the other hand, thumb drives get lost all the time. And then, of course, there's cloud. People storing things in the cloud. All those work. Let's better go to another one. All right, just a minute. I have a couple questions. Oh, okay. There. Yeah. Avoid any embarrassment. I will use the quicker mode. OneDrive is cloud. Yeah. Okay. Yeah. Goodbye. Oh, okay. Oh, well. Because everybody vote never. What? Okay. All right. I got. If you save it in the cloud, oh, gee, longer than a month. Right. It wasn't never. Okay, let's take a look. You can see the results. 42% of the people said sooner than a week ago. Very good. About 17% said a week ago. Only 8% said a month ago. But 33%, a third of you, longer than a month. You have to think, how much effort will it take to recover your data? If you lose something, what's it going to take? Let's stop this one and look at a very similar question. We will. There we go. How about on your phone? So last time you backed up the pictures and data on your phone. Okay. All right. Well, the results here in class, almost everybody did frequently because they have cloud backup. About 22% cloud backup, 22% a week ago. Nobody said over a month ago, but maybe longer than a month. And one person said never back up your phone. Well, that's okay if there's nothing on your phone you want to ever keep. If it is something you want to keep, you might want to back it up. Because the next question, have you ever lost your, we're going to do this. We're just going to let this go. Yes, well, I've lost data several times. I hope not many times. And I work real hard. I've got, when you say lost, is it really lost, or just sort of misplaced? Sometimes data gets managed. I have to go get it from my backups. And I have to cover data. Yes. I had a mistake this afternoon. I was fumble-fingered. The spreadsheet go up, got to back up, get an old version, start again. Okay. Big thing is, how much can you afford to lose? Well, in an industry, your data may be all you have. Your proprietary information, if you're a software development company, your source code, that is the assets of your company. You lose that, you've got nothing. And think about what you have on a personal basis. what will it take me? Particularly as you're typing along, how often do you press the save button? If you've typed all afternoon, never saved it, and then if something happens, you could lose that. Obviously, what is the effort involved in creating the data? What is the cost of pressing the button? Doesn't take much. You have to, again, what's the risk analysis? What's the cost of the loss of data? What's the cost of backing up the data? And what's the probability that a failure will occur over a period of time? Those are basically the three inputs values. Often the cost of backing up is not very high. The cost of loss is extremely high. So that means you should do a backup. And you have to look at how often you do it, and how often it's likely to fail. I just mentioned as you're working along, save the information. It just takes one little click. Save that stuff. I know some people go for quite a long time before they click it. My wife will spend a week with something open on her desktop and she never saves it. Sometimes it disappears. Some systems back it up immediately. There are systems that do a backup every time. I remember database systems that every time a change was made to the database system, it automatically copied the change, what the data block was before you changed it, what it was after, copies it out to the system. So at any time, if there's a failure, they can back up to a given point, take their backup copies, run them through the system, get that database exactly where it was before the failure. You can imagine systems that have remote servers, that have a server someplace in a different city. I know that the server system that they use for lotteries, lost it for a minute there, for lotteries. If you buy a lottery ticket, sends information off that somebody at this store bought this number, because you want to make sure that if you have a ticket that says, I have these numbers, and at the end of the week, they pull out, knows your numbers, you take the ticket down to the lottery people, you don't want to say, we didn't sell one of those. Yes, I did, I have it here. You don't want them to lose that data ever. And so their server collects the information, and as soon as it gets it, immediately sends it to another server in another city. So you really have to destroy a lot in order to take out all the information. There are also RAID systems. I talked about RAID systems before in this class. Real quickly, a RAID is a redundant array of independent disks. Long ago, it was a redundant array of inexpensive disks. It's using multiple disk drives paired together to make it look like one large virtual drive. Not only is it large, but it can have data recovery. If something fails, if the disk fails, you keep on going. There are multiple types of RAID. 0, 1, there's also 2, 3, and 4. Nobody uses 2, 3, and 4 because 5 and 6 and 7 are much better. Depends on which one. But you know, skip disk 0 just makes it faster, but it just breaks the run. With RAID 1 is real simple. It's mirroring. You have 2 copies. You have 2 disks out there. Everything that's written to one disk is written to the other. So the disks are always absolutely identical. If one of the disks breaks, no problem. You still got the other disks. You can then, many of the systems, when you have a server like this, if a disk drive fails, lights start to blink in the cabinet, the technician goes over, pulls out the broken disk, puts a brand new disk into that slot, the operating system, then copies all the stuff from the old disk or from the current existing disk onto that one. And in a little while, you've got 2 disks again. There's also other systems that you can use multiple disks. I might point out the disk controller that fails. I've had that issue. We had a system that had RAID disks, and the disk survived, but the disk controller broke. And if you split the files across some of the systems, put a piece of the file, the first block on this disk, second block on that disk, and the next block on this disk. That way it can read them all much faster than read everything simultaneously currently from each disk. Unless the disk controller breaks, then the disks themselves are useless. Okay, basically when you do backups, the usual backup system is that every day you do some sort of incremental backup. That is, you back up those new files and the ones that are modified. If you buy a commercial backup system, and there's lots of them out there. I've got one that I use, and every night it backs up any new files I created and any files that I updated are backed up from whatever directories I told it to back up, ignoring the directories I told it I don't care. And then on a semester basis, quarterly basis, whatever it is, back up everything. Just do a complete backup, so you have a backup copy. All sorts of media you can use depending on, cost, speed, how fast is it, reliable, how big is it, lifespan, how long will it last. Several, there's CDs, which are fine. You can write them once. There are write once, read many times. They go up to about 6, depending on the CD, 670 megabytes. DVDs go much bigger, up to gigabytes. Memory sticks, the USB thumb drives, those get pretty big. I just bought one that's 128 gigabytes. So that's a pretty big memory stick. It wasn't all that expensive, but on a dollar per dollar basis, it was kind of dollar per byte. Remote servers, where you have, again, a server someplace else, you copy everything to the remote server. That's very expensive, but very fast and very effective. External hard drives, those are kind of it's almost the same as a USB concept, but they're a little bit more expensive. Then there's commercial drives, commercial services, where you can have your data saved in the cloud. That's very effective. And it's an expense, it's a recurring expense because they charge you usually on a monthly basis. So there's tape drives. Don't use a tape drive. In my experience, tape drives are the most likely device to break in a computing system. Don't ever put a tape drive in your system. Where are you going to put that data? That's very important. If you keep your backups right next to your computer and there's a fire, it's going to burn your computer, it's going to burn your backups, you're out of luck. You want to have a copy someplace else. I worked for an organization many years ago where at 3 a.m. in the morning, they did a incremental backup every night. On Fridays, they did a full backup, everything. And on Fridays, they took the complete set of tapes down to the bank, put them in the vault, and got a couple of weeks later, some old tapes from a few weeks old, brought those back and just cycled through big crates of tapes going down there. Yes, they used tapes. They were terrible. Oh, yes, this is interesting. This happened. Some poor graduate student was working on his thesis. He was almost done. And being conscientious, he backed up his, this is back in the days of floppy disk, he backed up his thesis to a floppy disk every night and put that in a box carefully labeled. Well, somebody stole his computer and they stole that box of floppies that was right next to it. So he lost everything. He was back to nothing. Note that while the information on your computer may be quite secure because you've got all sorts of password encryption, if you back it up, you have a separate copy and they don't have to go through the operating system to get it. If you back it up on a thumb drive, somebody can just put that thumb drive into their computer, read the information, and see it. Encryption really helps. You should encrypt your backup data so that nobody can see it. Cloud backups work very well. Again, they usually encrypt the data, and they usually have a regular schedule. Okay, let the old computer guy give you his example. This is recommendations for a whole bunch of things, computers. Use an antivirus out there, and make sure it updates regularly. If you have a network address translation will help you. That's where the computers inside your network have one network address, but that address is changed as it goes out through usually your router. And so nobody on the outside knows what computers. It looks to the outside world like you have one computer, one very busy computer, and they don't know what's inside. So they can't attack your computers because they don't even know where they are or what they are. Firewalls, again, do that. Both firewall software on your computer and your router should have a firewall. Disable the auto run feature. When you insert a DVD or thumb drive, it's nice to have you put that music in there, it starts up playing. Yeah, but that means any DVD with whatever it has that you put into the machine, it will start it. You might not want to always start it. Disable that feature. It just takes one little click to start it. But you don't want things starting that might not be what you want. And passwords, we talked about passwords. You need strong, long passwords. Always keep your system up to date. And look at what's starting automatically. Well, if you're on a Microsoft Windows system, well, both of them have, look at the task manager, right click the taskbar or Control-Alt-Delete, look at the task manager. You can see the programs that are running, and you can see what programs automatically start. It gives you a list of some of the programs that start automatically. Are those programs you really want to start? I've gone out and disabled a whole bunch of programs that start. A lot of computer software manufacturers believe the only reason you'd ever want to turn on your computer is to run their software, that you'd never want to use it without their software. And so they start things automatically for you. Well, if you're not going to use that software but once a month, don't start it automatically. It will start up when you start the program. Maybe it'll take a few milliseconds longer. And most importantly, don't let things start that you don't know about. Don't know what they are. Now, some things are out there that you have to start. This machine has a application that makes the mouse work. If that doesn't work, it's kind of clumsy. So that needs to run. On the other hand, don't start things that you don't need. Yes, and when you load a phone app, don't give it access it doesn't need. My favorite was I loaded a astronomy app. Oh, they're cool. You point in the sky, it shows you where all the stars, put the labels by all the stars. Except this one tried one, it wanted to have access to my contacts. Why does an astronomy app need access to my contacts? No, get rid of that one. No. If it doesn't need it for the purpose of that app, don't let it have it. Watch for browser plugins. Every now and again, go out and see what plugins are on your browser. You might have things you have no idea how they got there. Take those out. And again, watch for phishing. We've talked about that. Big thing is the return address is wrong. They're sort of generic. Another thing I've noticed about phishing attacks, frequently all the text will be in a picture. That's because the antivirus systems don't do text interpretation of the picture. You can read the text in a picture, but the software doesn't. So it flows right through the system. They just think it's a picture of a cat or something. They don't know. So if all the text is in a picture, that's a big giveaway. And of course, grammar. A lot of these things come from other nations, created by people who are not native English speakers. So, watch out. Again, I'm stealing a Togo picture for Walt Kelly. Remember, you can destroy your data all by yourself. You don't need anybody else to do it for you. So take care of it. That's it. On Wednesday, we will have a class, usual time and place, and I'll talk about what's going to be on the final. Review for the final, try to give you some hints as to what will be on the final. The final will cover all the material throughout the semester. I will try to give you some hints on Wednesday about what exactly you want to be ready for. But that will be. Any questions? Okay, hearing none. If you are exempt from the final, then you're done. You don't have to attend the class on Wednesday because you've already got your grade. You don't have to take the final. So I hope you had a good semester. Good luck in all your other classes. That's it.